Good evening. Ain't out from last class?
No, sir.
Okay. In last class, I defined you different types of wave. One is longitudinal and then transverse. And on the basis of which I define you how to calculate velocity of transverse wave and longitudinal wave. Next thing is equation of traveling wave. As for SHM, that is simple harmonic motion. Equation was y equals to a times sine omega t. It means it is defining just oscillating particle about their mean position. Up and down, up and down, up and down. But for wave, it must have vibration about their mean position as well as propagation along the string from one point to another. So to define it, equation will be y equals to sum a sine omega t plus or minus k times x. It means it will have two different components. One is time dependent to define its oscillation about their mean position, and the other is x dependent to define its propagation or traveling from one point to another along x-axis. Let me define you its meaning. Here, y is displacement of particle. A is maximum displacement. Which is also called amplitude. Next is omega. Angular velocity. So it will be equals to 2 pi by t or 2 pi into frequency. Next is k. Angular wave number. So k is 2 pi by lambda. Next, this x, y, z at this point attached with k, it will define you direction of traveling of wave or direction of propagation of wave. With its coefficient, there is plus or minus sign. So plus sign will define you negative axis and minus sign will define you positive axis. It means if you have plus sign in between these two parts and with x, so you'll say the wave is going towards negative x-axis. And if you have minus sign in between these two terms with x, you will say wave is going towards positive x-axis. Atif, is it clear?
Yes, sir.
Now this entire term, that is angle of the sine, is called phase. So we may write it as phase of this entire term. Just write it down to this part. You all have written?
Writing, sir.
Okay.
Done, sir.
Now, first question related to this concept will be, if y equals to 0.02 cos pi by 2 times x minus 2 pi by 5 t. Find first wavelength, second time period, third direction of propagation of wave. Let me define you how to solve. Just compare this part to the above one. Coefficient of x in this part is pi by 2. So it is called k. Coefficient of t in this part is 2 pi by 5. So it is called omega. And coefficient of cos is amplitude. Next, there is negative sign in between these two parts, which will define you nothing but direction of propagation. So first, coefficient of x, we have pi by 2. So it will be k. Just equate it to 2 pi by lambda to find lambda. Next, coefficient of t, we have 2 pi by 5. So it will be omega. Just equate it to 2 pi by 2 pi by t to get time period. To define direction of propagation, try to find this variable. Here we have x, and with sign negative. So we can say this wave is propagating towards positive x-axis. Abhinav, is it clear how to define direction of propagation of wave?
Yes, sir.
Okay, try to find rest two term, lambda and time period. Atif, you got any answer?
Sir, I don't know if it's only for me, but your screen is like glitching.
Even for me, sir.
Like they're like black rectangles.
Okay. Is the similar issue for all of you?
Yes,
Yes,
sir,
sir.
there is.
Okay, just 1 minute. I'm rejoining just 2 minutes, okay?
Okay, sir.
Hello, is it clear now?
Yes, sir.
Atif?
Yes.
Okay. So on comparing this k, which is equals to 2 pi by lambda, pi by 2, pi cancel out. So lambda, you will get 4 meter from this part. And if you put omega to be 2 pi by t equals to 2 pi by 5. So 2 pi cancel out. So t will be just 5 seconds. Yusuf, is it clear?
Yes, sir.
Okay, write it down. Yusuf, done?
Yes, sir.
Now from this part, next question will be relation between phase, path, and time difference. Phase difference, path difference, and time difference. According to the above formula, pi equals to a times sine omega t minus of kx. So this angle with sine is called phase. So you may write phi equals to omega t minus kx. This phi is depending upon two different factors. One is time dependent and the other is position dependent. So let's say in first case, t is constant and x is constant. So for t is constant, let's say phi1 equals to omega times t minus of kx1 at some position x1, and phi2 equals to omega times t minus k times x2 at some different position x2. So if you subtract these two parts, omega t and omega t will cancel out. So you will get phi1 minus phi2 equals to k being constant, keep it outside, and x2 minus x1. This term is nothing but delta phi, and this term is nothing but delta x. So if you put the value of k to be 2 pi by lambda times delta x. So this is called phase difference, and this is path difference. Riba, any doubt? Next, if x is constant, so phi1 will be omega times t1 minus k times x for some instant t1. Again, phi2 equals to omega times t minus kx at some t2. So just subtract these two parts. So this term and this term will cancel out. So you'll get phi1 minus phi2 phase difference equals to omega being constant, keep it outside, T1 minus T2. So this part will define you phase difference times omega, and this is time difference. If you substitute omega to be 2 pi by t times delta t, so this will define you phase difference in relation with time difference. Rehab, is it clear?
Yes.
Okay, just write it down. Yusuf, done?
Almost done, sir.
Okay.
Done, sir.
If y equals to 0.04 times sine pi by 4 times t minus pi by 2 times x, find phase difference if delta x is 0.5 meter, second delta t is 1 by 4 second. Just use the above formula. On comparing, you can say coefficient of time will be omega and coefficient of x is k. So using formula, delta phi equals to k times delta x. Put the value of x and k from this part and simplify it. Again, delta phi equals to omega times delta t. Put the value and simplify it. Abhinav, any doubt?
Sir.
Sir, I can't send the answers to you, sir. When I'm trying to send, it's saying you're not in the meeting.
Is it visible now?
Yes, sir,
Atif?
your message is visible.
So if you substitute coefficient of t is omega, that is pi by 4, and delta t is 1 by 4, so you'll get pi by 16. Phase difference for this part. And similarly, in this part, k we have pi by 2 and delta x 0.5, so it will be pi by 4. So just remember these formula. You will be asked directly to find phase difference and part difference related to this part. Yusuf, any doubt?
No, sir.
Sir, I can see your messages, but when I'm sending, it's saying you're not in the meeting. I don't know why. I'm not sure if anyone else is having this problem. So let me leave the meeting and join again. Maybe it'll be fixed.
Just 1 minute. There will be some issue. You all have written up to this part?
Yes, sir.
Yes,
Yusuf?
sir.
Okay. Now next, related to this part is velocity and acceleration of particle in wave as y equals to a times sine omega t minus of kx. So in this part, A is amplitude, omega t and kx, two dependent term. One is time dependent, other is x dependent. So we have to calculate velocity. Velocity is dy over dt. So you must have to differentiate it with respect to t. So on differentiating with respect to time, since we have two different variables, I'm just taking one at a time. So it will be termed as partial differentiation, represented by this. This is actual differentiation, and this is partial differentiation. Partial differentiation of y with respect to t. So a being constant, keep it outside. Differentiation of sine is cos omega t minus kx. In this part, I'm taking t as variable, so its coefficient omega being constant, keep it outside, and differentiation of t is just 1. So dy over dt will be particle velocity equals to omega times a cos omega t minus kx. Now in this part, cos, whose maximum value will be 1, so velocity of particle maximum will be omega times a. Atif, is it clear?
Yes.
Next, to find acceleration, on differentiating further with respect to time for this velocity equals to omega a being constant, keep it outside. Differentiation of cos will be minus of sine omega t minus kx, and coefficient of t in this part is omega, and differentiation of t will be just 1. So this will define you particle acceleration minus of omega square a times sine omega t minus kx. Maximum value of sine will be 1. So maximum particle velocity or maximum particle acceleration will be minus of omega square a. Riba, is it clear? Okay, just write it down. You all have done?
Writing,
Done,
sir.
sir.
Done, sir.
Now, there will be a question to define relation between particle velocity and phase or wave velocity. So let me define you. Particle velocity and phase or wave velocity. Suppose in a wave, particle will be vibrating about their mean position like this. Creating a disturbance which may propagate along this way. So there is two different motion in this part. One is these different particles are vibrating up and down about their mean position. So the velocity with which particle will be vibrating about their mean position is called particle velocity. So first is the velocity with which particles of wave will be vibrating about their mean position is called particle velocity. So it is equals to omega times A cos omega t minus kx. This particular vibration of particle will create a disturbance. So its maximum value is at this point, and the next maximum is at this point. So distance between these two maximum, that is crust, will be called lambda. And time duration for this part, from this point to this point, is time period. So we may define this propagation of disturbance along the string as called wave velocity or phase velocity. So phase or wave velocity. The velocity with which disturbance propagates along the medium is called wave velocity. So V is equals to distance by time. Distance we have lambda, time taken is t. So it will be lambda into frequency, as 1 over time period will be f. And further, it will be equals to omega by k. Atif, is it clear? Okay, just write it down.
Sir, can you scroll up? Okay, sir.
Yusuf, done?
No, sir, writing.
Okay.
Sir, what's after vibrating in particle velocity?
Vibrating about their mean position.
Thank you, sir. Done, sir.
Rishan, any doubt? Now, next we have to compare or relate these two parts. So let me define you how to relate. As displacement equals to A times sine omega t minus kx. So if you differentiate it with respect to x, you will get dy over dx. A being constant, differentiation of sine will be cos omega t minus kx. We are differentiating with respect to x, so coefficient of x, that is k in this part, will be variable. Differentiation of x will be just 1. This term will define you nothing but slope to that particular curve at that instant times cos omega t minus kx. Now we have two different parts. One is particle velocity and the other is slope. So if we divide these two terms, on dividing, particle velocity divided by slope of curve at that instant. Particle velocity we have omega times a cos omega t minus of kx. And for slope, we have minus ka cos omega t minus kx. So a will cancel out, cos omega t minus kx, cos omega t will cancel out. So you're left with just omega by k, which is nothing but velocity of wave. So from this, we can say particle velocity is minus of slope times wave velocity. Atif, is it clear?
Yes, certainly.
Now, from this part, let me define you what we can calculate. Suppose in a wave, there's a particle at this point, let's say A. There's another particle at this point, let's say B. So you will be asked in which direction this A or B will be going at this instant, whether it will go upward or downward. So how to define its motion at this instant? For this type of problem, just draw tangent to that particular instant. Take a horizontal line to it. So the inclination of this tangent at this point is negative theta 1. Similarly, for point B, if you draw a tangent and draw a horizontal line to it, so inclination of this line will be plus theta 2. So according to this above relation, we may define velocity of particle at point A is minus of slope, that is tan theta, which is in negative. So it will be minus of tan theta 1 multiplied by wave velocity. So minus and minus will become plus v times tan theta 1. It means particle velocity at point A is in positive. It means it must be going up at this instant. Abhinav, is it clear?
Yes, sir.
Similarly, for point B, minus, slope at point B is in positive, so it will be tan theta 2 multiplied by velocity of wave, so you'll get minus v tan theta 2. It means particle velocity at this point is in negative, so it must be going downward at this instant. Aisha, is it clear?
Yes, sir.
Okay, just write it down.
So the screen is glitching again.
Sir, can you scroll up? I can't see the top part. Okay, sir.
Atif, is it glitching again?
No, sir, no, it's not.
Okay. Yusuf, done?
I'm writing, sir.
Okay.
Done, sir.
Next is reflection of wave or pulse. Suppose pulse is sent along this direction on a string which is connected to some movable end. This end is free to oscillate. And suppose a pulse is incident along this direction to any fixed end. So what will happen to its direction and phase difference? In first condition, since this end is free to oscillate, so it will tend to oscillate according to direction of or shape of pulse. So on reflection, there will be no change in phase, only direction of traveling of wave get reversed. So it will be incident wave and it will be reflected wave. Only there is difference in that direction. Phase difference will be 0. So in first part, y incident will be a times sine omega t. It is going along positive x-axis, so it will be minus of kx. And reflected one in this part is a times sine omega t plus kx, since it is going along negative x-axis. And phase difference in this part will be 0. But in case of rigid support, on hitting this particular pulse, it gets reflected back, but in opposite direction, like this. So this will be incident and this will be reflected. So y incident is going along positive x-axis, sine omega t minus of kx, and y reflected, a times sine omega t along positive with some phase difference pi. So from this part, we can say phase difference in this case will be pi in these two different parts. Is it clear? So in case of free end, only the direction of wave will get reversed, but phase difference will be seen. In case of rigid or fixed support, direction will get reversed and also both differ in phase by pi. Atif, is it clear?
Yes.
Okay, just write it down. Yusuf, done?
Yes.
Now, using this concept, let me define you concept of standing or stationary wave. A string is connected to any fixed support at this point, and a wave is created along this way. Since this particular end is fixed, so on reflection, its direction will get reversed. Like this. So this wave is incident wave, and after reflection, it gets reflected back along this direction. If we proceed this wave backward to this point, so if you draw projection, this wave and this wave, which is along same direction, so difference of these two parts will be pi. That's why we can say phase difference between incident and reflected will be pi. Now, on superimposition, these two different waves, let's say y incident is a times sine omega t minus of kx, since it is going towards positive x-axis, and reflected wave is a times sine omega t plus kx plus pi, which may be written as minus of sine kx, as sine theta plus pi will be equals to minus of sine theta. I'm using this part in this expression. So this will define you incident wave, and this will define you reflected wave. So on superimposition or adding these two waves, on adding y equals to y incident plus y reflected, take out a as common. So you're left with sine omega t minus kx, first part, minus sine omega t plus kx, second part. Now we have two different terms. This is first angle, and this is second angle. So let me define you one identity related to this part. Sine of C and sine of D equals to 2 times sine. I'm assuming this part to be C, which is larger as compared to this part. So this is C and this is D. So we have C in negative and D in positive. So if you simplify it, you'll get C minus D divided by 2 cos C plus D divided by 2. Atif, any doubt?
No.
So using this identity, if we simplify above part, so y will equals to a and there will be some negative minus 2a sine c minus t, that is omega t plus kx minus omega t minus plus kx divided by 2, first part, and cos c plus d, that is omega t plus kx plus omega t minus kx divided by 2. So in first part, omega t and omega t will cancel out. Kx will cancel out. So you'll get minus 2 times of a sine kx and cos omega t as final expression. Now in this result, we have two different segments. One is t-dependent function, and the other is x-dependent function. And these two in this part is separated with one another. So we can say this is a standing wave. Now you'll be asked, what is the main difference between standing wave and traveling wave? Let me just show you. In case of traveling wave, omega t and kx will be together. Just say this. We have one bracket and both omega t and kx will be together in this part. But in case of standing wave, kx and omega t must be two different functions separated with one another. So this is how we can differentiate traveling wave and standing wave. Is it clear?
Yes, sir.
Okay, just write it down to this part. Yusuf, done?
Writing, sir.
Okay.
Done, sir.
Okay. Now in this part, we have two different terms. One is time dependent term, that is cos omega t, and the other is x dependent term, that is sine kx. So this particular term will define you two different points. One is called node and the other is called antinode. We have this particular point at which displacement is maximum. So this is called antinode. And this point when displacement is minimum, so this is called node. So using this part, we can say node is a point where amplitude is minimum 0. So sine kx will be 0. Sine n pi equals to 0. So on comparing, you will say kx will be equals to n pi, or x is equals to n pi by k. If you substitute k equals to 2 pi by lambda, so you'll get n lambda by 2. It means x is equals to, if you put n equals to 1, 2, 3, so it will be lambda by 2, 2 lambda by 2, 3 lambda by 2, and so on. It means you'll get node at these different positions on the string. Similarly, for antinode, that is maximum amplitude, the value of sine kx will be maximum, and it will be for 2n minus 1 pi by 2. So you will get kx is equals to 2n minus 1 pi by 2, or x is equals to 2n minus 1 pi by 2k. If you substitute k is equals to 2 pi by lambda, you will get 2n minus 1 lambda by 4. It means if you put x is equals to 1, then you will get lambda by 4, x is equals to 2, 3 lambda by 4, 5 lambda by 4, and so on. These will be different points on which you will get antinode on the string. Atif, is it clear? Riba, any doubt?
Please.
No, sir.
We just write it down. Yusuf, done?
Sir, writing anti-node.
Okay.
Done, sir.
Now for this part, you'll be asked if y equals to 0.08, sine of pi by 4x and cos pi t. Is it standing or traveling wave? Velocity of wave? Amplitude of actual wave? Rehab, just tell me, is it standing wave or traveling wave? Aisha? Riba?
Standing wave.
Good. Since we have kx and omega t in different parts, so it must be standing wave. So it must be standing wave. Next, we have to calculate velocity, for which we just need two different parts. One is omega and the other is k. So coefficient of x is k and coefficient of t is omega. So we can say omega is pi and k is pi by 4. So velocity of wave is omega by k, that is pi divided by pi by 4. So pi and pi will cancel out. So you get 4 meters per second. Atif, is it clear?
Yes.
Now, how to calculate amplitude of actual wave? So in this part, we have total amplitude 0.08. So if you compare to the above part, you can say on adding or superimposition, amplitude becomes double. So if you have to get amplitude of actual wave, so it must be half of it. So 2a equals to 0.08. So a is equals to 0.04 meter. Abhinav, is it clear?
Yes, sir.
Okay, just write it down. Yusuf, any doubt?
No, sir.
Yusuf, done?
Writing, sir.
Yusuf, done?
Yes, sir. Done.
Okay. Now, this is standing wave on string. Similarly, there is another superimposition which is called beats. Suppose there is a wave this is one wave in which full complete oscillation. So we can say its frequency is 4 Hertz. Let's say another wave having 2 complete oscillation. So its frequency is 2 Hertz. Let's say this is B. Now, if these two waves overlap over one another, so they will produce like this. Since in first wave, direction of pulse is along this way and direction of pulse is along this way. So both these two will tend to add on each other. But at this point, direction of these two waves get reversed. So they will tend to subtract it. So wave start decreasing. Similarly, at this end, direction of both these two are along same direction. So it will tend to add. And at this end, it will tend to subtract. So it will create a wave like this. So in this part, we have two different terms. A point having maximum amplitude is called loud sound, and a point having minimum amplitude is called faint sound, loud sound, and faint sound. Similarly, faint sound. So one complete loud and one complete faint sound is called beat. So we have one beat at this point and one beat at this point. So we may define beat as when two waves of different frequency superimpose over one another produces a combination of loud and faint sound. This combination is called beats, and the number of beats produced by them in per unit time is called its beats frequency. So next is number of beats produced per unit time is called beats frequency. Just write it down. Abhinav, any doubt?
No, sir.
Yusuf, done?
They're writing the definition.
Okay.
Done, sir.
Okay. So we have to prove this particular term mathematically also. So let's say one of the wave is a times sine omega 1 into t. We may write it as sine omega is 2 pi f into t. And the next wave y2 is a times sine omega 2 into t, which is a times sine 2 pi f into t. So on adding, y is equals to a being common. So it will be sine 2 pi f1 into t plus sine 2 pi f2 into t. We have two different parts in this expression. So we may use the above identity. Sine of c plus sine of d is equals to 2 times sine c plus d divided by 2 multiplied by c minus d divided by 2. So using this, let's say this is c and this is d. So you will get a times 2, that is 2a, sine c plus d divided by 2. So it will be 2 pi f1 plus 2 pi f2 divided by 2 into t cos 2 pi f1 minus 2 pi f2 multiplied by t divided by 2. So on solving, you will get 2 sine pi bracket f1 plus f2 times t cos pi f1 minus f2 times t. This is resultant expression. So in this term, we have two different expression. One is f1 plus f2, and the next is f1 minus f2. let me define you these two parts according to the actual graph. In graph, we have two different function frequency. F1 is 4 Hertz and F2 is 2 Hertz. So there will be another curve like this. So in this part, we have two different terms. One is this term, which is 2, which is nothing but F1 minus F2. And the other is this part, which is nothing but F1 plus F2. So we can say on superimposition of these two different waves having different frequency, you will get two different waves superimposing over one another to create a loud and faint sound. So which frequency will be termed as beat frequency? You will say the difference part of these two terms. So in this part, we have two different expressions. First is this one, and the second is this one. This is called beat frequency. Riba, is it clear?
Yes, sir.
Just draw this.
Done, sir.
Yusuf, done?
They're almost done. Done, sir.
So from this part, we can say beat frequency is equals to difference of frequency of two waves.